This is geometry, section 10.6. We're talking about circles, and we're talking about circumference and arc length. So, a couple definitions. The radius of a circle, you've probably heard that word before. So if we draw a circle, the radius goes from the center straight to the outside of the circle. So it's the distance from the center to the outer edge of the circle. The diameter happens if I go all the way across the circle. So if I have two radii that are basically back to back in a straight line. So a diameter is a straight line across the circle going through the distance, or going through the center of the circle. Sorry, so two radii, plural of radius is radii. So it's two radii put together on a straight line. Whole distance all the way across the circle going through the center. So that's drawn out here, the diameter. The circumference of a circle, you've probably heard that word before as well. So the circumference of a circle is the distance all the way around the circle. So the length all the way around the circle. It's basically, you can think of it as the perimeter of a circle, the distance all the way around it. So there's two formulas that we can use for it. Most common one is 2 pi r. You're going to want to remember that one. That's a big one that comes up a lot. So circumference of a circle is 2 pi r. We can also write that as just pi times the diameter, since 2 times the radius is going to give you the diameter. So since this is a radius, 2 times that would be a diameter. Pi times 2 times r is the same thing as pi times the diameter. And pi, as you probably know, is approximately 3.14. If you type it in your calculator, when you are trying to calculate something, you're going to want to type in the pi button on your calculator, because as you might know, it goes on longer than that, longer than just 3.14. 3.14 is just an approximation. All right, so let's use this formula. So it says find the circumference, give your answer in terms of pi, and also to the nearest tenth. So this is our radius of this circle right here. So if we take 2 times pi times 5, we would just multiply these two numbers together, 2 and 5, and get 10 times pi. So when it says in terms of pi, it just means just put a number with pi. When it says rounded to the nearest tenth, it means actually multiply that out. So we would take 10 times pi. Your pi key is going to be right here. You have to hit the second button first. So 10 times pi gives me about 31.4. Okay. Right here, it gives me the diameter. So if I use this formula, all I have to do is 24 times pi, or pi times the diameter. And we always write pi kind of like a variable. So when we write something like 24x, we would write it as 24x, not x24. So the pi always comes after the number. Okay, so when I type that in, 24 times pi, I get 75.39. So that 3 is going to round up to a 4, so 75.4. This one, it doesn't give me any measurements. It gives me the circle on a grid, so I just have to count either the radius or the diameter. So the radius would be 1, 2, 3, so the diameter would be 1, 2, 3, 4, 5, 6. So it's going to be 6 times pi for the circumference. So when I multiply that out, I get 18.8. Okay, find the radius to the nearest tenth. So now if it tells me the circumference is 100 pi, well, I know that circumference, the formula for it is 2 pi r. So if it tells me the circumference is 100 pi, I can set 100 pi equal to 2 pi r. So then I want to solve for the radius. It's telling me to find the radius, so I just get rid of this part, get rid of the 2 pi, divide by it, since all this stuff is being multiplied. So I divide by 2 pi. Pi is going to cancel out. 100 divided by 2 means the radius is going to equal 50. Same thing over here, 45, circumference is 45, so it equals 2 pi r. I do the same thing, I divide by 2 pi, but now I don't have a pi up here, it's not going to cancel out. So I have to go to my calculator, 45 divided by, I have to be careful when I type this in. If I type in 2 pi, then it's telling my calculator, take 45, divide by 2, and then multiply that answer by pi. But I want to multiply, or I want to divide by 2 and pi. So when I type it in, I have to put that in parentheses, telling my calculator, okay, I'm taking 45 and I'm dividing by 2 and pi, the whole thing. So I need to type it in like that. Gives me 7.16, so about 7.2 centimeters. Okay, arcs and arc measure. So an arc is a piece of a circle. So if I have a circle like this, an arc is if I take the circle and sort of cut out a chunk of it. An arc is just this length right here. We can think of it sort of as a fraction of the circumference. So the circumference is the length all the way around the circle. An arc is if I just take a chunk of the circumference. So we measure arcs in degrees. When we're talking about the word, when you see the word measure, you're talking about degrees. If you see the word length, we're going to be talking about something else, which we'll talk about on the next page. So when I'm talking about the measure of an arc, I'm talking about what's this angle of the circle that I've cut out of it. Okay, so this angle looks like maybe it's about, I don't know, 80 degrees. So I would say the measure of this arc is 80 degrees. So it's given by the measure of the angle that it intercepts, or the chunk of the circle that's cut out by that arc, measured from the center of the circle out to the edges of the arc. Okay, we also have things called a major arc and a minor arc. So a major arc is going to be an arc less, no, I'm sorry, a major is more than 180 degrees. And a minor arc is less than 180 degrees. So a minor arc would be less than half the circle. So this arc right here would be an example of a minor arc. A major arc would be if I went from here, let's say all the way over here. This would be called a major arc, okay? Because it's more than 180 degrees. It's more than half the circle. If I have exactly half the circle, that's called a semicircle, which you've probably heard before. Exactly 180 degrees, or half of a circle. Okay, also when we name an arc, we call these 2 points where the arc starts and ends, we name them. So for example, we could call this A, this B. We would notate it by using a little curved line on top of those 2 letters. So this would be called arc AB. We use this little curve on top of the letters to show that we're talking about an arc and not a line segment or something else. All right, so find the measure of the shaded arc. So we have to figure out, well, what chunk of the circle does it cut out? What is the angle that it cuts out of the circle? Well, this is 90, which means this vertical angle is 90, which means all these angles are 90, all next to each other. So the shaded arc is 3 chunks of 90. 3 times 90 is 270 degrees. So this arc would be 270 degrees. This circle is cut into 5 72-degree chunks, and this arc is covering 1, 2, 3, 4 of them. So 4 times 72. 4 times 72 is going to give me 288 degrees. This is cut into 60-degree chunks because this is 60 across from each other right here, 60 across from each other right here. These 3 angles have to add up to 180. 60 plus 60 plus 60 equals 180. So I know these 2 chunks right here are 60 degrees. Add them both together. 60 plus 60 means this arc is 120. Okay, so when we're talking about the length of an arc, the actual length of it in feet and inches and centimeters, whatever we're measuring the circle in, we're going to set up a proportion to find that. So we already talked about the measure of an arc. Okay, so we're going to compare the measure of that arc. So how much of the circle, for example, this was 270 degrees, 288 degrees, and 120 degrees. So the measure of the arc compared to the whole circle, which is 360 degrees. So we're going to compare those 2 numbers. Those 2 numbers are going to be compared to the length of the arc over the entire circle. So the entire circumference would be the length all the way around the circle. Okay, so circumference, or 2 pi r. Okay, so we're always going to compare the arc measure, or the degrees, over 360 to the arc length over circumference. All right, so we have the same 3 circles that we just did up above. So we know this was 270. This was 288, this was 120 degrees. Now we want to find the actual length of the arc. So we're going to use this proportion to set it up. So this one's going to be 270 over 360 equals x, because we're trying to find the length of the arc, over the circumference. Well, the circumference I find using the radius. So it's going to be 2 times 12 times pi. 2 times 12 is 24. So it's going to be 24 pi. So now, to solve a proportion, we know that from a couple chapters ago, we're just going to cross multiply. So 270 times 24 pi gives me this number, 20,357.5, I think it was, and then equals 360 times x. So we're just going to divide both sides by 360. So I take this number, divide by 360. I get about 56.5. 56.5, and these two tick marks right here means inches, so 56.5 inches. All right, this one's measured in feet. I know my angle is 288, so I compare 288 to 360. My circumference, now my radius is 9, so I take 9 times 2, 18 times pi. Whoops, that needs to go on the bottom. Sorry, circumference goes on the bottom. So 18 pi. And then x, we're trying to find our arc length. So that goes here. Same thing, cross multiply. 288 times 18 pi. We get that number. And then the same thing's going to happen with this one where it equals 360 times x. So we're going to have to divide that by 360 again. So we get about 45.2. And this one is in feet. Same thing over here. Angle 120 over 360. We found this angle up above. 260-degree chunks equals x, our arc length. We're trying to find the length of this over our circumference. So now our radius is 5. 5 times 2 times pi, 10 pi. So 120 times, whoops, not divided, times 10 pi. And then same thing's going to happen, times or equals 360 times x. So we're going to have to divide by 360. 10.47 would round up to 10.5. And this is in centimeters. All right, find the indicated measure, round to the nearest tenth. So now anytime we're dealing with arc length, arc measure, anything like that, we can always use that proportion that we set up at the top. So here, let's figure out what we know and what we're trying to find. So we're trying to find the circumference. If we set up our proportion, follow the proportion we wrote down up above, circumference goes on the bottom over here. So this is going to be our x because that's what we're trying to find. So x. Our arc length is given to us right here. It says the length of this arc is 22 feet. So I'm going to put that where arc length goes. The arc measure tells me this angle right here is 55. So that goes here. And arc measure is always compared to our total of 360 degrees. So same thing, I cross multiply, so now I have 360 times 22 gives me that number, 7920 equals 55 times x. So I have to divide by 55. Divide by 55. I get that the circumference is 144, and this is in feet. Okay. For the next one, I'm trying to find the measure of the arc, trying to find this angle from P to W, arc PW. So that's the first piece right here. That goes on the top compared to 360. I'm comparing it to the whole circle. Tells me that the arc length is 20 inches, and it doesn't give me the circumference, but since it gives me the radius, I can find it. 8 times 2 times pi would be 16 pi. Same thing, cross multiply. 360 times 20, and then we're going to have 16 pi times x. We're going to have to end up dividing by 16 pi. So 360 times 20 to start. And then I'm going to have to divide by this whole thing because I'm going to have 7,200 equals 16 pi times x. So I'm going to have to divide by 16 and pi. Remember, when we do that, we have to be careful to put it in parentheses to tell our calculator, I want to divide by 16 and pi, not just by 16 and then multiply by pi. So you have to put that in parentheses, and you get 143.2. And this is in inches. All right, last one. We need the length of A to B. So this arc right here, which means I'm not going to use this angle right here because that's this piece right here. To find it, this is making a straight line, so I just take 180 minus this chunk, which is going to give me 150 for the measure that I'm looking for right here. So I'm going to have 150 over 360 equals my arc length, which I'm trying to find, over my circumference. If my radius is 16, then my circumference is going to be 16 times 2 times pi. So we should be getting the hang of this by now. We're going to have to multiply these two, and then we're going to have 360 times x. So once I multiply these two, I divide by 360. My final answer, got that done over here, we've got 41.9. And this is in inches again.